the API and the SDKs are not something that we provide on top of the releases. Sorry, a little more. These are also used internally by all the software in the robot. So all the services inside the robot use the Spot API, as well as the Python and C++ SDK. So it's always the case that with every release of the robot and the SDKs, everything is up to sync in terms of the functionality that's there, as well as what the robot provides, plus what the API supports. And the third point here is we also provide a very good set of documents in the dev.bostondynamics.com website. So for there, you can take a look at, there's a lot of high-level concepts for API services, as well as more detailed information that we'll touch base in a few slides later. But that's a great place to start with a lot of the information of what we provide with the API. Thanks. And so this slide is sort of a history of how the API has evolved over time, as well as introduction of what's in there. As you can see that these are only the major and minor versions. On top of this, there's a lot of dot releases that we make as well. But we are heavily involved in maintaining this API and the SDKs that go with it. The first release, 1.0, was in January of 2020. This is around the time where Spot was also available through the lease program. And that was the initial set of all the services that we provide. In 1.1, which was just a bit later, we provided a few more core services, as well as the mission concept, which we'll talk next, which came fully baked in version 2.0. So the autonomous navigation for Spot is one of the main functionalities, meaning that Spot is designed so that you can record a mission and then being able to play it back autonomously many, many times. So this helps with with inspections, any type of missions that you'd like to continuously do over time. So that came really early in the API, and then we continue to mature it over time up to now. The other part that came in 2.0 was the Spot Cam, which is one of the main payloads. This is the PTZ Pano IR type camera that you can purchase with Spot. In 2.1, the big change here was the data acquisition API. So as part of those mission recording and playback, we provide the functionality to being able to capture data as part of those playbacks. So as you're adding new sensor or new payloads, this API allows you to easily integrate those payloads with the rest of the ecosystem in Spot so that you can acquire images or any type of data through the mission playback functionality, as well as to teleop with the tablet. In version 2.2, docking was the big change. So this is when the docking hardware was available, and so the API came with it. The 2.3 was the introduction of the arm and the gripper. So the API for the arm and gripper control was available, as well as the next thing is the network compute bridge, which is very applicable to probably what a lot of you are trying to use the robot for. So this is how you can incorporate external machine learning models and computer vision applications that process the data that is captured by Spot, either in real time or post-processing. In version 3.0, this was a lot of changes that there's too many to list in here. The map processing for missions was a big one, the auto return functionality. So the idea is if the robot is lost, we have some control and concepts of what to do when that happens and how the robot should go back to its dock, for example, as well as the choreography and constraint manipulation API. In version 3.1, big one was some lease changes. So this is the lease system is controlling who has, or making sure that someone has control of the robot and coordinating the control between various users if multiple users are connected to the robot. In version 3.2, which was in August of last year, the big change here was the auto walk functionality. So we talked about missions in version 2.0 that was introduced, but that API for missions is quite complex. It's a set of behavior trees definitions that on how the internals of the mission definition was done. And that was really hard for external developers to parse those proto definitions and being able to modify them. So auto walk is sort of the higher level API definition of missions. Internally, the robot still uses that detailed definition, but at least the auto walk API allows you to have a more higher level concept of what the mission is and how to change it if that's necessary. In version 3.3, the big change was service customization. So a lot of these applications that external developers could implement and add, now we provided the options to also provide parameters for those applications, so that the application developers will tell the Spot system, here are the parameters that my application supports, and those would be fully integrated with the tablet that Ed showed, as well as the Scout part of interface, so that when you're recording a mission, you can take advantage of those parameters that are available through the application that you implemented. And then we're currently working on version 4.0, and that's going to come soon. Next slide. All right. And so the big thing here that Ed also mentioned is that Spot is fully designed as an extensible platform. And this is from a hardware perspective as well as a software perspective. For hardware, it's designed so that you can continue to add payloads. And then on the software side, through the API, we're making sure that you can easily integrate those payloads with the current concepts and the ecosystem of Spot. So we talked about data acquisition API. So this allows you to write applications that easily collect data from any payload, and then being able to integrate that as part of the missions and teleops functionality in Spot. Machine learning models through the network compute bridge, any mission extension nodes. So the idea here is if you'd like to do certain behaviors as part of the mission, you can definitely extend that and make it part of the fully integrated solution that then you can use for recording as well as teleop. And then again, all is fully integrated and out of the box through the API and the SDKs. And the SDK provide a lot of helper functionality around this, not just having to write the protos or the API messages yourself. There's a lot of helper functionality based on the use cases that we've seen and how to make your job easier. And then as of right now, there's also a partner integration solution. So this API and SDKs is not just used by us, but there's partners out there that are currently using it. And I'm sure there's going to be a lot more going forward. As an example, Fluke provides the SV600 acoustic sensor. So that is that middle payload there that you can see with multiple microphones as in the center. And so that also comes with a data acquisition plugin that runs inside that payload that is able to integrate with a mission service and being able to collect acoustic sensing data during missions. And the other case is Levitas and Reply provide a lot of computer vision and machine learning models that run on the Core IO. And then they provide various types of functionality, such as gauge reading and other things. Next slide. And related to those, so Ed touched base on this as well, is to say, how do we implement and run those additional applications that are integrated with the rest of the Spot ecosystem? And that's what Spot Core IO extensions come into play. So we have this simple functionality that we built on top of Docker images that allows you to create these applications, Dockerize them, and then install them and manage them on the Spot Core IO, so that it's easy for any applications to be bundled into an extension and then just upload it to the Spot Core API, to the Spot Core IO, and being able to run and fully integrate it with the rest of the Spot system. There's a lot of details here, of course. So at the high level, it's mostly just based on industry standard Docker images. And there's an UI, as you can see on the web admin console from the Core IO. But the full documentation is also part of that link that we specified in this slide. And with that, I'll hand it over to Andres to talk about a few cases on how this is used.
Thanks, Spiro. All right, so we're going to touch on a few use cases of the Spot API as a research and Spot as a research platform. The first application we want to look at today comes from Meta's fundamental AI research team, and it's called Adaptive Skill Coordination for Robotic Manipulation. And it's exactly the sort of application we envisioned when releasing Spot as a platform for researchers in the first place. They're using Spot as a stable, ready-to-use platform for getting robots to do pick-and-place tasks, like get the bowl from the table and put it in the sink. So they used the built-in behaviors that ship with Spot as the core of a small library of skills for navigating, picking, and placing. And those skills also included a learned component that wrapped around the built-in behavior to adapt it to the sort of household environments that they wanted Spot to operate in. So they pre-trained those skills, and then they jointly trained 2 additional networks, one that coordinates which skill to execute at any given moment in time, and another that adjusts the output of the skills to account for environments that weren't seen during training time. They then took all of those networks and ran them directly on the hardware with no fine-tuning in the real world, and had about a 90% success rate in their test environments that they used for doing these pick-and-place tasks. This really embodies what we're trying to go for here. We have a quote there from our general manager, Zach, that your science project should be your research, not the robot. So Spot gives the researchers a stable platform to use that they can focus on the interesting research questions they actually want to get to the bottom of. Now, our next application is, if we could move forwards, thank you, is from a university research and industry research partnership between Luleå Technical University and LKAB in Sweden. And here they had Spot deployed in the world's largest underground iron ore mine. And the focus was on combining Spot with aerial vehicles to make operations safer and more autonomous inside the mine. So they're specifically developing missions for Spot that can be used in post-blast inspection, monitoring production areas, and accessing areas that are too risky for them to send humans to. So they have parts of the mine that no one has been in for years because they're too dangerous, to the point where had the robot failed during those missions, they would have just left it there. And now they've been able to get data from those areas and get eyes on it. And so if we go to the next slide here, we'll see an image of Spot decked out in the LKAB blue with one of the drones that they're using here. You can see it perched on the back with some green rotors there. And so Spot, the researchers at LTU developed the ability to use Spot as a mobile access point for these drones. So Spot will carry a drone through the network of mining tunnels. Spot is connected to the Wi-Fi network that they actually have inside the mine. And then upon arriving at, say, a mine shaft, the drone can deploy and maintain its network connection by connecting back to Spot and then back to the main network. So this really expanded the realm of what they could do in terms of autonomous inspections inside the mine. And it worked out really well for both sides here. So this partnership gave the university researchers at LTU the opportunity to apply their research in a very real world situation. And it let the folks at LKAB get a much more accelerated view of what the ROI could be for this technology, that they might not have had the technical resources in-house to do themselves. And so for our final case study here, I want to look at some work we did with Ontario Power Generation on circuit breaker racking. So go to the next slide. Let's just have a couple definitions here. So racking is the industry term for removing a circuit breaker physically from the bus that it's connected to. And on the sorts of very high power breakers that they have in facilities like OPGs, there's a risk that as the breaker is removed, a spark will form between the breaker and the bus. And there's so much power going through these circuits that if that were to happen, it will vaporize the metal around it and form an explosion, which gives you this arc flash and arc blast, which is very dangerous to humans. It can result in death. And so when people go in to do this, you'll see them in bomb suits. And even then, if something goes wrong, it's not bad. It's not good for them. So our customer OPG actually had a situation where one of their breakers was malfunctioning. And they, after doing a bunch of practice in their innovation lab with the Spot that they have, they were able to use teleoperation to rack this malfunctioning breaker out. And the only part that a human had to be involved for was putting that ratchet into the socket, which is a relatively low risk, although they still have to wear the bomb suit, part of the process. So we saw this and we were very impressed by what OPG had accomplished and really excited by this. But we wanted to see if we could make it easier for Spot to be used in situations like this. So notably, it did take about 45 minutes to rack out the breaker. They had to put an extra camera in place to give better situational awareness to the operator. And someone still had to suit up in the bomb suit and insert that ratchet. So we developed a solution based on this idea, and we'll see that in action in the next slide here. So here, Spot is carrying a tool, and it takes a picture, and the user indicates where the breaker is by tapping on the image in the tablet. And then we get a closer look from the gripper and repeat that. And then Spot's going to go ahead and do a final fine localization step by touching off against the emergency trip switch cover. And this is going to give it the accuracy that it needs in order to push the trip switch that's under that cover. So there's a very tight clearance, especially from front to back there. Should note that we have our camera operator at fairly close range here. This is not an energized breaker. So then once you've pushed the switch, which wasn't actually shown here, but once you've pushed the switch, you can then, the Spot then grabs this ratcheting tool that we printed and attached to the back, and it'll select the direction that we want to rack. In this case, we're racking the breaker out. So it sets the direction of the ratchet, picks up the tool, and then it'll go ahead and insert that. So the tricky part with the insertion here is there's actually a trapdoor covering the drive socket. And so you'll see the robot push that little metal trapdoor down and then insert. And then once it gets started turning, we're going to speed up the video here so you can actually see it moving the breaker out. But all in all, our final version of this can do the tripping and racking sequence in around 5 minutes, which is a big improvement on the 45 minutes that it took earlier. And so as to how this is all put together, if we go to the next slide, we'll see a bunch of the elements that Piro talked about in the API are really what drove all of this. So we wrote a mission by hand rather than using the auto walk service that Piro mentioned, because we had a more complicated flow for how the action needed to happen here. We wrote that mission, and it got sent from the Spot tablet to the mission service, which then coordinates running a behavior tree that calls out to other built-in services on the robot, like our robot command service or the image service, and also calls over to these remote mission services. Now, these were the only part here that's custom for this application. So the green boxes you see there are built-in Spot components that ship with every Spot. The dark blue box there, remote mission services, these are things that we wrote specifically for this application to do things like localize the trip switch from the image, push the switch, do all of the manipulation of the grasping tool using our impedance control. And all of those remote mission services made API calls back over to the services on Spot in order to actually get Spot to do the actions that were required. And so all of the things that were used here are included in the current Spot release, with the exception of the tap-in image functionality, which hopefully we'll include soon. And so with that, we were able to go from having to suit someone up in this very uncomfortable bomb suit that still exposes you to some harm, to having the robot do the operation in an automated form with minimal user input. And with that, I'll hand it back to Ed for next steps.
Excellent. Thank you, Andres. So really the next steps, if you feel like Spot could be a good fit for your program, our team is happy to consult with you. We're going to actually share a QR code in one of the next few slides here, so that if you'd like to access our sales form and submit your information, someone from our team will follow up with you and we can get some time set up to speak. But really, our team's very consultative. We want to understand your program, what you're hoping to accomplish, and then ultimately get you the configuration that's appropriate for you. So with that, I think we're going to transition to a few questions for the remainder of the time.
Yeah, thanks, Ed. And thank you all. Yeah, we've got some great questions. And just a reminder, please use the Q&A button below to submit your question. There's a lot of questions. I'm afraid we probably won't have time to go into all of them, but we will be following up and reading all of those questions and making sure we get you some answers. To kick us off, I flagged this question a little bit earlier when you were talking about, Ed, the different, basically the academia version. And I want to clarify this question because they asked, what are the key differences between the academic version and commercial version? Is there a link to spec differences? And I think you could probably answer that pretty well. So go for it.
Yeah, sure thing. So the kind of easy way to answer this one is that we only have one version of Spot. Really, we sell the robot as a mobility platform, and then you can either purchase additional payloads that are specific to your use case. That was why, we designed the academia kit. That is kind of a common configuration we're seeing amongst customers. So we created a packaged kit around that. But all of those payloads can be purchased a la carte if desired. But there's no difference between the robot we would sell to a commercial organization versus a researcher. It's the very same robot, same software releases. The only difference is the payloads that might be relevant to you, your use case, and your applications.
Yeah, our goal there is just to make it easier. We're seeing a lot of folks, like for example, in the more enterprise industrial application, we know the types of kits and payloads that those folks need. So it's really a recommendation, but you're not locked into those things. And like Ed mentioned earlier, we'd love to hear more about what you're trying to accomplish, and then our team can really help make some of the right recommendations for what you need. This is a pre-submitted question. Are there opportunities to use Spot in K through 12 classrooms?
Yes, of course. We actually have, I would say, 5 K through 12 educators. So still on the earlier side, but still a handful of folks who've already purchased Spot robots today. And really, these are educators who are developing a project-based curriculum around Spot, folks who are developing curriculum around our Python-based SDK. And I'm happy to say this is kind of a soft announcement. This is the first public platform we've talked about this, but we're working with an educator who's planning to actually release a public version of their project-based curriculum in the next 6 to 8 weeks. So within the next 2 months, there will be a public modular curriculum for Spot. So if you purchase a Spot robot, you don't then have to go create a curriculum from scratch. You can use this one that our longtime customers already created. So we're very excited about that. We've been working with them on that for a long time. And I think there's a lot of excitement around that. So hopefully it just makes it easier for someone who, if you're kind of a K through 12 organization or secondary school and you're thinking about how could I add a Spot to my program, we want to work with you, and folks are doing that today.
Great. So there's a few versions of this question asked a couple different ways, but please elaborate on the customization capabilities, i.e. access to lower level hardware via API and ROS integration.
You like me to
Piero,
answer?
you want to take
Yeah,
that one?
sorry. Yeah, Piero, sorry. I didn't want to call on someone, but yes, Piero.
No worries. Yeah, and we do get this question a lot. I think the easiest thing to do right now is to go through the choreography API that we have public. So this would be anyone can create a set of lower level controls that you can make Spot do. It's not going to be as easy to say, I want to add a new gate to how the robot moves and does perform those low level tasks, but that's the closest we have right now. And this, just wanted to say that this has been a consistent discussion point internally as well. So even though we don't have something right now, we always keep discussing this as being part of something that might be available externally. As of right now, we're focusing a lot more on making sure that the robot is as robust as possible. So, focusing on making sure that it doesn't fall or all the gates work as perfectly as possible. But definitely later on, we're always discussing how to extend this to provide more control to low level API for the robot.
Just to add a nuance to what Piero is saying there, for the ARM, we do have direct joint level control available to you through the API. And so as part of that meta example that we were talking about, their adjustment network was actually directly adjusting the joint targets for the ARM live over the API.
Great. Here's an interesting question. Can AutoWalk be trained on one course, then autonomously manage a very similar course? Example, same obstacles, but different environment. I don't know if Andres or Piero can speak to that one.
I would not expect that to work well. if the AutoWalk map recording is going to look at the kind of fine-grained details of the environment for localization. And so if you tried to run it then in a different environment, unless you built them exactly the same way both times, it's very likely that the robot would have trouble localizing in the new environment. It's really meant to record in place and then execute in place.
Great question.
And yeah, as Andres, I just wanted to add a point as well. Yeah, so if the environments are very, very similar to each other, and let's say you put the fiducials at the same exact spots, and so you try to make it as identical as possible between the two environments, you might have some success, but as Andres mentioned, like it's designed so that you record a mission in one area and then you can easily play it back in that area.
Yeah. That being said, it was designed to be robust to smaller changes in the setup in that area. So we have, robots that run missions around the office here, and pallets get left in the hall, and they still navigate fine around those. But an entirely different location might be hard.
So you led into my next question. Is Spot able to identify autonomously objects, paths, and anything else to go from a start point to target destination without human support? Do you want to talk a little bit more about how Spot can adjust its path?
I can start with that, yeah. So the idea is if the robot is, let's say, docking is the first step of it, because the docks all have the fiducials that are part of the initialization as well. So and on top of that, there's the near maps as well as the no-go map views that provided as part of the navigation system. And so it's related to having the maps as well as the fiducials in the place to state, and as part of the mission playback that would allow the robot to navigate autonomously and localize itself and being able to replay the missions in that environment.
But as far as getting around obstacles while executing those missions, that is all happening live and based on the sensor data. So it uses the map to tell which hallway to go down, but then as it's traversing the hallway, it can see, oh, someone left a desk chair here. I'm going to go around that. Obviously, Spot doesn't know it's a desk chair. It just knows that there's something in the way. But that doesn't need the map. That's happening live. Even if you were teleoperating the robot with the tablet and you try to drive it into an obstacle, it won't walk into the obstacle.
Yeah, there's a more specific question on AutoWalk in a complex environment like mining, and that's of course one of the examples we spoke to was a mining customer. So I definitely suggest, if you're interested in mining use cases, we have quite a few of those examples on our website, among other industries as well, because all industries are quickly changing environments. Forklifts get left in place, barrels, you name it, and we recognize that, and we've worked really hard on optimizing Spot to work in those environments. So this was another question. More details on Spot's robot dynamics and degrees of freedom. How does mobile manipulation work? And I don't know if we can talk a little bit more about that, maybe Andres.
Sure, yeah. So the particulars of how the dynamic balancing works are all kind of hidden under the hood and abstracted away. The arm is a 6 degree of freedom manipulator, and you'll have full control of that, both in Cartesian control of the end effector, as well as joint level control. And we also have an impedance control mode for the end effector, which lets you do actions like when we were pushing the tool into the breaker, where you need to be compliant in some axes and stiff in others. So as you use the arm for mobile manipulation, the base will move to maintain balance. But you will receive through the API an indication of where the gripper is at any point in time, as well as where the base is. And so you can use that to coordinate for your particular application.
Perfect. This one is more specific about BIM models. So, and maybe Ed, we can talk about Virginia Tech, but really interesting use cases. Are there use cases to visualize Spot within a common data environment or BIM model for use in construction or facility management? I think that case study is probably a good one to refer to. I don't know, Ed, if you could add more color about what they did?
Yeah, sure. So I'm not sure if this totally relates to maybe wanting to like represent your spot in your digital twin or your BIM model or something of
Yeah.
that nature, but really the Virginia Tech use case was all about work in place verification. So they were using Spot combined with HoloBuilder, where they had Spot using a Ricoh Theta camera that the students had integrated. And as we all know, there's kind of a never-ending stream of construction projects on college campuses. At least, in my time in college, that was always my experience. And so, what Virginia Tech was doing was they're collaborating with Virginia Tech Capital Construction, who runs all the projects on campus. And so the students were able to take their Spot robot that they own. They were able to bring the robot onto the construction site on campus so they could do the applied research with the consulting companies running the project called Procon Consulting. And again, Procon was wanting the students to use Spot to collect all these images around the job site so that they could do work in place verification and just understand, okay, has all the electrical infrastructure been in place so that now we can bring in the mechanical infrastructure. Oh, do we need more materials? All of these kind of decisions that might need to be made from somebody traveling out to a project site. And so additionally, they also wanted to understand how could they develop safety protocols around the use of robotics in construction. So it was a really interesting use case around undergraduate students who are using Spot on their own college campus with their industry partner.
Great. There's an interesting question. The Spot in my lab seems to have a black and white camera. Are there RGB cameras? Can we talk about that upgrade path, maybe, Ed?
Yes, absolutely. So the good news is, if you choose to get a Spot robot, we won't preclude you from getting on the latest hardware, the latest software. Historically, over the 3 years that Spot has been on the market, we've always provided an upgrade path. So if we come out with a new hardware release or something of that nature, you're able to get on the latest. So the short answer is yes, we offer a RGB camera upgrade. So if you're interested, please follow up with me, or more likely we'll grab your information and we can send more information more directly to you around what that upgrade looks like. But generally speaking, that's something where you just have to ship it back to Boston Dynamics. We would have it for a maximum of 10 business days, and then we would ship it back to you thereafter. So you won't have a ton of downtime with your robot. We want to get you up and running again quickly, but still get you on the latest hardware as desired.
How do 2 and 3 Spot robots, can they work together to implement a task in the field, and how heavy an equipment can be mounted on Spot? So maybe just we can reiterate the payload capacity and talk about NASA JPL, I think is a good example of that, Ed.
Yeah, of course. So Spot again has a 14 kilogram or 31 pound payload capacity. So this means you can affix a lot of your own custom sensors and payloads to Spot, which what we've heard is just significantly more than what drones are able to handle today. And in that regard, what NASA JPL was doing was they had a robot, Spot robot with an arm, and 2 other robots. One was effectively kind of this the one with the arm was effectively going inside this cave, and they were simulating Martian cave experiments. So they wanted to take a Q-tip and swab the inside of the cave physically to understand if there was flora or fauna that might have been on the inside of the cave, and try to carbon date that and understand and get data around what organisms may have lived there previously. And again, all this was to simulate their potential experiments into Martian caves. But again, how Spot was collaborating with the other robots, one would take the swab, it would walk over to the other Spot, which kind of had the kind of like the sample kit on its back, so they could place the Q-tip in there and the sample wouldn't be compromised while they were able to send it or get it back to the folks at NASA JPL. So that's just a quick example. And then additionally, I'll just point to the fact that we have a written case study on that as well. So if you want to learn more about that collaborative robot experience that NASA JPL is exploring, please check out the article.
Cool. There have been some deeper technical questions that have come in Q&A that would be tough to answer in this format. And we do invite you to check out some of the links that we spoke to earlier on developer documentation. There's a lot of great resources that we've referenced throughout this webinar, so be sure to go back to the recording and get those links. But if you are interested and you want to raise your hand and talk more about pricing and talk to us more about your application, please feel free to reach out directly to sales in the follow-up email that you'll receive at the conclusion of this webinar with that recording, or you can use your QR code on the screen. But we really appreciate everyone's time and showing up today and checking out our webinar. We're glad to have everyone. Thank you all. Thank you to the team for presenting.
Recording stopped.